Okay, we're going to talk about order of operations. An order of operations has to deal initially with being able to simplify, okay? And that's the big deal. Sometimes that's all we're trying to do, right? So if you've got this big long problem and you've got to simplify it down to a single answer, right? Because it's got equals on the end, and so that's what the students are trying to do. So order of operations is initially taught with that in mind. And all you're doing is simplifying a fairly complex problem, okay? And doing order of operations often comes with this example. If you Google order of operations, what is order of operations? This is the answer that it gives you, okay? But it's not. When I actually ask what is, okay, this is how to, not what is, okay? So we're going to just scratch this off for a minute, okay, and talk about what is the order of operations, okay? It is the set method to simplify operations. Okay? Now, in doing that, we're also going to take numbers and combine them and do different things with them through those operations. And so our numbers will get simpler. We don't always get just one answer though, okay? And simplify is a fairly common math term that we use, okay? But this is different than solving. Solving is when we're dealing with two sides of an equation and we're working to get them to equal each other, okay, and show that they equal each other. Simplifying is what we do to each side of the equation to get it into its simplest form, okay? Solving is when we can connect and move across the equal sign with different rules, okay? But simplifying all deals with one side of the equation or the other, okay? And you can simplify both of them at the same time, but if you're not working with their connection to each other during that, okay? So simplifying this, and we use these operations. Now, the operation order that we typically think about is PEMDAS, okay? So PEMDAS is a nice setup that we've used. Please excuse my dear Aunt Sally. Lots of different ways that you may have remembered this, okay? Parentheses. Exponents. Multiply. Divide. Add. Subtract. Okay? Now, when I first am going to teach about order of operations, I'm probably not going to include exponents in there. And from the other videos in this section, you're going to learn more about exponents than you ever knew that you should know. Okay? Parentheses may or may not be in there, okay? But parentheses are often used to break up this order of operations if it needs to be done in a different order, okay? Sometimes we put them in there just to clarify that order, and that's really helpful for us as we see lots of different things. I put in parentheses, and then I automatically think that must be done first, okay? And so that's helpful if we understand that. Our students, after we teach them about order of operations, are going to go and try and do parentheses first. So anytime I use parentheses, it's kind of a trigger for them. This is something that we're doing right here, right now, before other things. Okay? Now, PEMDAS has worked for many years, but we're getting some issues in. Okay? Because as I look at this, I've got my 4 basic operations in there. Okay? Just in this and the setup, students will think that addition must come before subtraction. Okay? and multiplication must be done before division. This is not true. Anytime that I use PEMDAS, I separate these out because we're really dealing with multiple levels of operations that have to be done, some before others, right? Anything that's in parentheses does need to be done before any of these other ones. Now, it doesn't, within the parentheses, then I still follow my order of operations, okay? And that might be a bit of a tricky thing for students to understand initially, okay? So this, we learned about a certain kind of symbol that's kind of like parentheses, but it always comes out positive, right? It's those straight up and down lines, absolute value. Okay? Also, apart from the parentheses, there's a grouping symbol called brackets. These are all part of the same first step. Okay? The second step, exponents, the comboed operation with exponents is roots. So making sure that we put those two together and they're done at the same time, okay? So anything done in parentheses then gets simplified with all the others. Our exponents and our roots happen next. Multiplication and division are on the same level. That means that they are worked from left to right, okay? So if I have multiple things being divided, I start on the left and I move towards the right. Okay, if I have a combination of multiplication and division happening within the same problem, I start on the left and I move to the right with those. Okay? The same setup is for addition and subtraction. They are on the same level and they're done left to right. Exponents and roots are also true. Parentheses typically work from like the inside, the smallest, and work your way out and left to right, okay? So understanding this and that multiple levels going on within that, there's a couple other variations of PEMDAS that are becoming more popular. One that I saw in one of the classrooms not too long ago was GEMDAS. I like JERMDAS. JERMDAS has several of the same things in there, okay? E is exponent still. M is multiplication. Division. Addition. Oh, not that many of these. And subtraction. Okay? Which means we have an R in here right after exponents. Going back to what exponents were in the other one, roots was the other part of that. Okay? So here are still roots. G includes parentheses now, but is not limiting our idea, as we call it grouping symbols. Okay? When we think about grouping symbols, we're not only including parentheses, but now also the brackets and absolute value and whatever else might come into it. Okay? So doing this, it kind of lays it out. I can see more of what's happening, but I still have to include that operations are working at levels, and they're still the same 4 levels. Okay? Grouping symbols are again all combined, and the first thing that needs to be done. Exponents and roots follow, then multiplication and division, then addition and subtraction. Each of these are left to right. Okay? Grouping symbols are smallest to largest. Okay? So that means the smallest one, I simplify as much as I can. Some of them, if they're the same size, not going to make a big difference unless they're interacting with each other. Okay? Which, for our levels of mathematics, they usually are not going to. But as I'm dealing with this, you get a lot of interesting practice. So you've got a couple of worksheets available that help you make sure that you're doing things in the right order and that you understand that the order of operations for simplifying is set up in this kind of way. Now, order of operations when it comes to solving is going to be different. So, understand that this has to do with simplifying single sides of an equation. The relation between the two is going to be a different set of rules. Okay. Things to also really think about is distribution. Okay? When I have distribution, it is putting parentheses in there, and I've got something sitting outside, right? If I have something like 4 plus 3 in there, do I have to do the parentheses and add that, or is distribution going to break my order of operations? Well, this is a stupid example, okay? Because right here, it doesn't matter. Really? No, it doesn't matter, okay? Because how this works out doesn't change my end result, okay? If I were to do the addition in the parentheses and get 7, and then times by 5, I get 35, right? Okay? If I do the distribution and do 5 times by 4 is 20, plus 5 times by 3 is 15, I still get 35, okay? They are exactly the same. It doesn't change anything. So this is kind of a dumb example, okay? Not that these are going to still be equal, but this doesn't justify the need for doing distribution. Instead, we need to do something just as simple as 4 and put in a variable. Okay? Because now I'm asking about like terms. Can these be simplified and combined? Nope, they can't. So distribution has to happen. I've simplified this as much as I can. So if anything about the parentheses is like going to an exponent, then I can deal with that. But a lot of times we aren't to that kind of a setup, and we're going to just distribute through multiplication. Okay? So those kinds of things, when we have these all set up, is going to be way more important for us because they have to distribute instead of doing the parentheses. By showing the necessity there I see distribution has to happen and how it happens. Okay? So that's really important for us to bring up. Okay? So you may also think about like terms. If you remember, like terms mean that they have the same variable. And we'll get more into that when we get into simplifying expressions, which is really simplifying, okay? But expressions are only one side of an equation, so we'll get into that later. The other thing that's kind of interesting that students often, more advanced students, will look in at, and they're seeing things in a different way. Okay, so if I have 4 times by 7 minus 5 plus 3. Okay? A student may look at this and being able to see the subtraction, in their mind they rewrite this as adding a negative rather than subtraction. And rethinking about this in that way has an advantage because now I can pull in the commutative property. Okay? So my order of operations isn't changing, but how I'm approaching it and seeing all the operations does change. Okay? And so this is a really interesting thing that I've had a couple of students, and especially my advanced students, being able to see and do. Whether or not they were taught that and shown it, I don't know, or if it's just some way of thinking about it. When I'm having a hard time with how something's set up, this is my fallback that I'll go to, taking and changing things in the operation of them. Okay? So now I can reapproach that, because I know the rules about adding integers, and I'm very comfortable with that. But looking at this, I might mess things up. I don't know. Okay? Another way that I've also seen students look at it would be if I have 27 divided by 3 plus 4, right? They've got multiple things going on. I actually had a student who looked at this as timesing by 1/3. By doing that, these aren't the exact same. The end result is the same. And understanding, being comfortable enough with fractions might be an approach that happens with you and your students that will take you a little bit out of your comfort zone. But now you've seen it, explore it a little bit more, because it might be what helps you to solve problems much more easily and fluently. Okay?